Hi everyone, welcome back. This is Raju from Smart AI Technologies. In this video, I am going to demonstrate you a chronic kidney disease detection using machine learning project. So in this video, we are going to see introduction of the project. Within that introduction, I will be explaining about what is the chronic kidney disease and how it is being caused and what are the different stages are there and what are the treatments are available. Then we will be discussing how much minimum cost for each type of treatment in India, and then we are going to see what are the different type of methodologies that we are doing in our project and what are the hardware and software requirements for this project. And then we are going to check for the base paper, and we'll analyze the base paper, we'll understand, and we'll see what is the existing system available. After that, we are going to discuss about what is our proposed methodology over the existing paper and whether our accuracies we are getting better than that paper. If we are getting better than that paper, how much we are getting, and what making that accuracy more than the more than the existing system. So all these things we'll discuss one by one. First of all, we'll discuss about the chronic kidney disease and its parameters and causes, treatments, everything. We'll understand what is chronic kidney disease. It is a situation where gradual loss of the kidney function over time. It means kidney will lose its function over a time due to many parameters. So what is the main role of kidney? Kidney will be able to filter out the waste products, excess fluids, electrolytes from the blood, maintaining the balance of the body fluid, and producing the hormones essential for various body functions. So when it need to do all these functions, when suddenly kidney fails to do all these functions, now these waste products can accumulate to a dangerous levels. So it will lead to several health complications. Now, chronic kidney disease you can also define as decreasing glomerular filtration rate. Is GFR is one of the parameters to say, okay, the filtration capacity, how the filtration is going on. So we are naming they are named that as a GFR. So this medical term says how better your kidney is processing. Now it is categorized into 5 different stages, and the stage 5th is the complete failure of the kidney, and it need to be treated with dialysis or replacement. So stage 1 2 you can treat it at the lower level where they are not that much harmful for the patient. Now what are the different causes of the kidney disease? Mainly diabetes oriented and hypertension. Okay, these conditions can damage the blood vessels in the kidney, reducing their ability to filter the blood efficiently. Okay? And then other cause includes glomerulonephritis and polycystic kidney disease, recurrent urinary tract infection, and prolonged obstruction of the urinary tract. Lifestyle factors such as smoking, obesity, diet high salt can also contribute to development of CKD. And one more thing here missing is that if they consume alcohol, that nowadays that is impacting a lot on kidneys. And then what is the health implication due to chronic kidney disease? It can lead rise for serious health problems such as cardiovascular disease, anemia, bone disorders, and electrolyte imbalance in the body, and which can impact, and these can impact on heart, bones, nervous systems. So in advanced stages, CKD can result in end stage renal disease, so ESRD condition, where kidney fails completely, requiring dialysis or kidney transplant, and sometimes it will be leading to a serious thing. Okay, now stages of kidney diseases. Five different stages are there. Stages 1, kidney damage with the normal or increased GFR. So the GFR range is given. For each stage GFR range is given, but you can see the fifth stage, they say it as a kidney failure. Entirely kidney fails here. It will not able to do anything at all. Now when it comes to treatments, this is most important thing that we need to discuss, because our methodology says we are implementing machine learning over the chronic kidney disease. If we are doing that, if we do machine learning over chronic kidney disease, is that much impact on the present existing treatment? Is that yes? Because here you see, for the treatment of this, it will cost around 15,000 to 30,000 per a month. Only for dialysis are like that, normal one. If it reaches to surgery level and post operative, it can lead to 5 lakh to 20 lakh, and more than that, it depends on so many other parameters. So we can see the amount, it's very huge comparatively. So now what if we have something that can give us, predict us whether that patient is having any chance of getting kidney disease or not? It would be very great. Before stage 5, if we find out the kidney disease, and the treatment will be easier for the patient. So that is the main purpose of going with the technologies, the predictive technologies. They will say, okay, if the present condition of the patient is like this, you will be having kidney disease, you will not be having kidney disease. So that will save a life. And as a second step, we are going to check for the methodology. What methodology we are using in our project, what step by step techniques that we are going to apply on the data sets, and what we are going to build. I'll discuss for that. First we are going to do the data set collection, then we are going to do the data pre-processing, and now after this, actually I will be technically presenting you exactly what I am doing at the when we will be researching the existing IEEE paper. This is the base paper for our project, and we will be analyzing this paper. While we will be analyzing, I will be telling you clearly what process we are doing uniquely than the existing paper, what accuracies that we are getting, and everything. Okay, now, so these steps we are following: data pre-processing, model selection and training. We are actually using multiple models, and model evaluation, testing, and model saving. Even I will be showing you some glimpses of the code, how I done those things. Finally, we are going to build a web application using Flask, HTML and CSS, and little bit JavaScript. Now, what are the different hardwares and softwares that you need? So when it comes to hardware, you can have any OS. There is no problem with OS. You can have Windows, Mac OS, or Linux. And better you go with a good processor. You need good processor to make the things faster and easier for you. And better RAM, always advantages. Minimum 4 GB RAM is needed. And when it comes to storage, you need to have minimum 20 GB or like that. Again, how much space you will be having, that much faster the system will be for training and validation and everything. If you have a graphics, it is lot better. And you need to have internet, and if we are testing it locally, you don't need internet for that. And when it comes to software part, in the OS you can have any type of OS. And when it comes to Python, and it depends which version of Python we need to use. So in our case, I go with 3.7 or 3.8. You can go with 3.11, 3.10. So it depends on the requirement. For now, we'll say Python 3.8 and higher will be better, but Python 3.7 also you can use. Any version of Python can use. So IDE, we are going to use Anaconda Navigator, and Anaconda prompt we use the most because we try to go with mostly prompt oriented handling of the Anaconda, and we are going to use HTML, CSS as well as JavaScript. We are going to use a Flask framework. For database, we are going to use MySQL database if you need login and register form in the website. Now these are the things are needed, and now we are going to see the paper. That's a base paper. What does that have, and what is the missing in that base paper? What is the research gap? And over that existing paper we are going to produce our own proposed methodology that would be better than the existing paper, so that we will get the better accuracies. I'll just show you few things, you'll understand. The present paper that we are going to see here, sorry, give me 1 second. Even we will be providing these papers to you. So this is that base paper. In this base paper they use lot many models that you can see here. They use SVM, KNN as well as ANN, and how much accuracy they are getting: 98%, maximum 99.3, 91.7. But when it comes to us, how much we are getting? We are using multiple models. And each model is giving their own accuracies. But you can see here, boosting algorithms, mainly we are going multiple boosting algorithms, so they are giving around 100, 1.00, they are giving around 100% accuracy. You can see the classification report. So our model is performing lot better than the existing paper. You can see here 100%. Finally we have a comparison graph. You see almost all models are going for 100. 1 means 100. So only gradient boosting classifier 98, and decision tree classifier 98, and KNN 98. Other than that, all the remaining models are going for 100. Okay, now we'll discuss about this paper from starting. So in this paper, what type of dataset they are using? They collected the dataset from the Kaggle, and it is having around 400 entries, or you can say 400 patient details or data. Okay, now how many features it is having? It is having around 13 features that I can show you here also, that dataset. This is that dataset which is having ASB, PSG, sugar level, okay, SU, RBC, PC. So finally a classification which is whether that a man with these features will be having a chronic kidney disease in future or not. And our dataset and their dataset is exactly same. They are also having 400 sample, we were also having 400 sample. They were having 250 sample labeled chronic disease and 150 no chronic disease. Exactly the same dataset that we are going with, and same number of columns, 13 input features and one target column. And in this paper they are actually taking around 340 rows for training and 60 rows for validation purpose. You can see here 60 samples they are taking for validation or test, 340 for training purpose, and they are using SVM, ANNs as well as linear regression as I mentioned. And again they are doing k-fold cross validation, and you can see here they are trying to explain about each model, what does ANN means, what is KNN means, or what is SVM means. Okay, they are explaining with the classification report equations. These are all confusion matrix based equations. We also getting all these parameters. Okay, and we are getting a lot better than this paper. They are presenting equations as well as values here. You see here accuracy recall 98%, maximum they got recall 99.5, but in our case we are getting recall specificity precision over 100% for more than one model. I'm not saying only one model, more than one model are giving me 100% accuracy, 100% recall, 100% specificity and 100% precision. So now what does the gap here, and what this paper is missing? So we are implementing and we're getting a good result. So we need to understand for that, because if you want to write any research paper, so you need to remember these things. You can't just do whatever you want and publish a paper. They will not allow. So you need to propose your own methodology which is better than the existing paper, and you should prove it with the numbers and values. So now we'll discuss with our proposed methodology, and with related to this paper, even I'll be trying to show you some codes also. And for support I can take some Google images, because it's very easy to explain you with images. Okay. The first part, when it comes to dataset collection, I also collected the same dataset with 400 samples and 250 samples and 150 samples. So 250 plus 150, 400. So let me draw and explain you. Okay, the first part, that is, as that paper is mentioning, there are around 250 samples for chronic disease and there are 150 samples for no chronic disease. It is very clear, they are even mentioning it in their paper. But what does they are missing? This scenario we call it as an imbalanced dataset. So they are not handling this imbalance problem. They are just going with the flow. They are taking as it is and they are building the models. But here there is a gap. They are missing the data balancing process. So we are filling that gap. So our research is, we here adding resampling technique. Resampling technique, we call it as an upsample. So in the upsample, we'll try to make this 150 rows equal to 250 with random sampling in the given data set. So finally what happened with the upsampling is that for chronic disease, if I have 250 rows, okay, for no chronic disease also I will be having 250 rows. So the data set will be balanced, and the balanced data set always gives a good result. Okay, so that's why we are filling one of the gap that the paper was missing. And then the paper is not presenting a lot about the null value handling. So in our case, how we are handling the nulls? So now what we are going to do is, we are going to use a technique called random sampling. To random sampling, nothing but again within this technique I am doing dropping the null values. It means if there is any empty value in the given data set, for example, if I am having an Excel sheet data set, if in a one column, if the one value is missing, we call that as a null. You should have null values in your data set if you want to build a model. So you need to handle it. So in my case, how I am going to handle that is, I am going to remove that row, or I am going to fill that with the main value accordingly. If I have an object column, I need to go for either drop or either I go for median. So I gone for dropping. So even when I go for dropping, I am getting a better result. So I am handling the null values properly here. Maybe the paper, maybe they are doing in the backend, but they are not concentrating much on this process. But this is the most important thing, how we are handling. What type of handling will lead to the sufficient and efficient way of handling will lead to the better accuracy. So I am having one thing special than the existing paper, second thing better than the existing paper. And the third thing is normalization. The paper is not talking about again this technique. What does normalization is? For example, if I have a column like this, and if one column is having BP, and these BP values are very high, 180, 200, 120, 180, like that numbers. So real numbers you can see here, BP 80, 50, 70, 90, like these values are there. Okay, 100, 90, 60. So now these are all values which are larger. So now what we'll do is, we'll take, either you can go for standardization or normalization. So you can do like average this. It means the maximum element you divide for all the elements in the column. Okay, otherwise standardization is there, x minus mu, x minus m divided by mu, sigma. So x minus mu divided by sigma. Okay, so you can go for standardization or normalization. In my case, I am going for normalization of the columns. So that is making a lot of difference. I will show you how the result will get impacted only just because of the normalization and no normalization. So we need to understand things with numbers and with values. This is normal KNN, and this after normalization, you see my accuracy rose to 96 only for KNN, because KNN was having less accuracy, and initially it was giving 82 and 68, and then it directly jumped to 96. So that is the importance of the doing normalization or standardization over the given data set. So that I am doing. Now you understood the thing. So if the base paper may not be concentrating on that, but we are concentrating or we are getting better accuracy. Now again, what extra technique that we are adding to it? So now the next part is, we are doing specialization in feature selection. The base paper doesn't say anything about the feature selection. They say only the label column will be output column, remaining column will be input column. What if we have a control over the selection of the columns? We need to select the best columns, the better columns. For example, I will tell you the real world scene. Okay, then you will understand. For example, you are buying a car. Okay, now there are so many cars and the same brand. Now you see car 1, car 2, car 3 are like that. So one is gold, one is red, one is black car color. Okay, but their HP is different, this HP is different, this brand is this version is different. So now when you see the car prices, is the car price varying a lot only based on color, or it is based on the engine type, or based on the type of a wheel, or based on the average it provides, based on the technology it is having? Here when you see all the features, the color feature will become not most important feature. It may be one of the feature, but it is not most important feature. So when you have so many features, when you feel some features are useless to decide, so we try to take that away, so that we will be having much impactful features to get a better prediction. In the same way, if we can predict chronic kidney disease using few number of parameters or features better, why you use other low needed? So how to handle this scenario? For that we are going with two techniques. One is the wrapper method and another one is the LASSO. So now what will happen of that is, this is after wrapper, and it rose to 98. It was 96, now it rise to 98 once I do the wrapper. It means I could able to select the better feature, so I could able to remove the less impactful features. And then you see here, when I do the LASSO, it is lot better. This is increasing 97, it was 96 again in previous once we do the wrapper. Now it's 97, 98. So it is lot better than the again that model or that paper. So like this we are going to do for decision tree. So that's why we are getting these 100 things, 100 accuracy, better classification report. So what are different models that we are using, we'll understand first. around 1 2 3 4 5 6 7 8 9 10 different machine learning models are being used here in our work. The first model is KNN. Okay, the second model that we used is decision tree classifier, and the third one is random forest classifier, adder boost classifier, and gradient boosting classifier, stochastic gradient boosting classifier, and XGBoost classifier, CatBoost classifier, extra tree classifiers with a LGBM classifier. Now these number of models we are using and their accuracies, you see, these models are giving almost around 100% accuracy. 1 2 3 4 5 6 out of 10 models are giving 100% accuracy, and their classification report, that is precision, recall, F1, they are almost 100%. So why and how we could able to get this much good value is that we done our own proposed methodology which is better than the existing, so we had a better chance of getting good accuracy than the present existing paper. So now you can publish any research paper based on this. This is a comparison graph. So once this is done, what we are going to do? Now we need to use this pre-trained model. Now we trained it. Now it will become a pre-trained model. This model, whatever we train, we need to take it and we need to integrate it into our front end and back end. So then there you need to do the predictions. So we are Smart AI Technologies. You can see here our channel. We normally provide so many demonstration of the projects on different sub projects, subtopics, maybe machine learning, data science, artificial intelligence. So within that, again, you can go with the domain level, agriculture domain, defense domain, health domain. So for each domain, we can define our own methodology for any IEEE paper that you bring, any conference papers, any journal papers. So we could able to make our own proposed methodology, then make it as a coding and make it as a working project. So we provide the complete project with the documentation, classes, mentorship. For that we normally charge accordingly. Which type of project is that? Whether it is on a deep learning and whether it is a multiple models, whether it is an NLP based, how many models are there, how the project is, and how much time it takes, all those things. So with a reasonable price we are providing all these projects, so you can approach us and you can get the project. And you may be seeing the video and you may feel okay, for everyone we are giving this project. It doesn't go like that. Whenever we will be giving you a code and the project, if you want any changes in the work, if you want something new, and if you want to inject us something different, we can add it. We can add according to your interest and we can update and we can give it to you. So now we'll see the demonstration of the project that we built. So this is a front end and this is a home page of our project. As I mentioned earlier, for front end we used HTML, CSS and JavaScript. For the back end we used the Flask. So I will be demonstrating a little bit about the code also, how the code is being written. So first we'll understand kidney disease. Now you need to upload the dataset directly. So even you can test it by giving the one user input. That also will do now. Choose a file. And now you need to upload. We will upload test one. So first we'll understand the basic information. So you can see here, when you click on the basic information, you will be able to get what that data frame is having. Okay, so these are all the things are there. These are all top head values. It means what are the different rows and columns are there: age, blood pressure, specific gravity, albumin, sugar, red blood cells, PUS cells, PUL cells, clumps, bacteria. These are columns, and I'm printing only top 6 rows. You can print the entire data set, but if you print the whole page will be going for that. Otherwise you can print so many other parameters needed. Okay, so what is the shape? 425. It means the existing paper that was having around 13 features, but in our case we are going 25 different columns. It means 25 features we are having, which is double than the existing paper what we saw. So this is also one of our upper end over the problem we are solving. So then we go for the description of the data set. And if you don't know what are all these in depth, if you need technically from A to Z, so you can approach us. I will be able to explain you A to Z what is this and how these things are coming, okay, and what is the importance of these features. And then you can get basic information about our data set. What are the different basic information, maybe what type of column is that, and what is the name of the column, and what type of data it is having, whether it is on float, int, object. And then you come and you add it to pre-processing data. So here, as I told you, in our data set there were null values. It means some empty values. You can see empty, nothing but like this. These are all empty. So we need to handle it. These are all empty. So before pre-processing, we are having age column having 9 missing, blood pressure 12, specific gravity 47, albumin 46, sugar 49, blood glucose random 44. Like this, had so many null values in our data set. And now for categorical column also it is same. Red blood cells 152, PUS cell 65, like this. Now what I will do is I will handle, as I mentioned, we handled our null values by dropping the null values, the null value row. Either you can go for fill NA, that means you can fill the null value with the mean, median or mode accordingly. So then once I do that, I will be able to get 0. You can see that 0 value. So before pre-processing and after pre-processing, I am trying to print out how many nulls were there, what we did to those nulls, how the problem is being solved. Now if I print the top rows, I won't find anywhere anything missing, because everything is now solved. There is no null value, there is no missing values. And then we go for EDA data. So it may take a little bit time because the dataset that we uploaded is having more information. So now you see, these are all different graphical presentations. So now we'll see the density graphs, where it will try to give us the insights. I will be explaining one or two, but if you approach us, if you buy our project, you will be able to explain everything that is visible to you and whatever we done. So here you see, what does this mean? What does this density graph mean? Age, it says 50. At the age 50, it says it is having highest density. Density nothing but the patients who are coming to that hospital with a chronic kidney disease, the age is between 50 to 60, 45 to 50. They are having more chronic kidney disease, that the patient number is more there. Okay, but when the age reduces from 50, the number of patients are having less. Okay, it means there is a high risk from the age 45 to 55 chronic kidney disease issue. So like this, you can understand about all the graphs. They will give, each graph will be giving you one useful insight. Now for categorical column, I will do it. It says normal with when you see red blood cells, okay, normal people are having 200 people are having normal, and abnormal type of red blood cells are by 50, around 50. And you can go and check for all these graphs one by one. We will understand this heat map. So this is correlation heat map. Now if you want to understand what these numbers are, let us take age from x-axis and sugar from y-axis, and the value is 0.22. What does this mean? Is that whenever the age of the patient is increasing, there is a possibility of 22% increase in the sugar level. The same thing reverse you see here, sugar and hemoglobin. When the sugar level is increasing, the hemoglobin will be getting reduced. So urea and hemoglobin, okay. So the relation, how one factor impacting on the another factor, and what is the probability of their relation. The correlation value range from 0 to 1, and if there is a negative value, it means it is an opposite way. If something increases, something decreases. So minus always indicates the opposite, and if it is a plus, it will be in the same way. It means if something is increasing, that also will increase. Now we're gonna check for EDA data too. So here we'll be getting set of graphs. We can visualize the graphs and get the insights like violin plots, box plots. The first one is the violin plot for the red blood cell count. How the red blood cell count is being distributed, where there are more number of red blood cells, what is the mean number of red blood cells count. And then comes relational plots, we say scatter plot of age versus class. It means how these relational plots give us the information that we need is, it is always the relation between the target as well as the input. For example, age for the CKD, chronic kidney disease, when the age is rising from 20 to 60 or 80 or like that, the chronic kidney disease is increasing. It means from age 25, 40, 60, with the age there is a high chance for increasing in the chronic kidney disease. So age is the main parameter. Then comes the sugar level. When sugar level increases above 1, there is high possibility that it will lead to the CKD, that is chronic kidney disease. And the same hemoglobin, when hemoglobin count comes below, okay, when there is a CKD, you can see when there is a CKD there is a less number of hemoglobin. For non-CKD itself, you will be having more number of hemoglobin. It means hemoglobin plays a high role. If you have better hemoglobin, if you maintain better hemoglobin in the blood, you will not be having chronic kidney disease. And blood urea is also almost direct. When the blood urea increases, there is a high chance of having a chronic kidney disease. So you need to maintain this blood urea below the 100 itself. You can plot few more drops which can give you a better insight over the thing. And here I have few models, okay, but these are only 3 models I could able to add here. But as I shown you this code here, I could have added this graph there better. It would have been more information, because I have trained for 10 different models. To each model, among them around 6 we are getting 100% accuracy, classification report and everything. But there I added only 3. I will update that to 10. So I will update that to 10 and we will be having all these things over there. And this will be having all the things, okay, confusion matrix, what is the training accuracy, what is the test accuracy, confusion matrix, and classification report, F1 score, recall score, precision score for all the models. Here only 3, but we will be adding all the 7 to here. Or sometime what will happen is, we will be already proposed some model, some students will be proposing their own model names, okay, in their presentation. So now in that case we can add according to your interest. If you want only XGBoost and ADA boost, that's fine, you can go with only XGBoost, ADA boost. Mainly our research was, when it comes to modeling, we concentrated more on boosting algorithms. You may heard about bagging and boosting algorithms. So under bagging, decision tree, random forest will come. Under boosting, they are improved version of, you can say, they are improved version of random forest, but they are not exactly same as random forest. But there is a way where we will remove those nodes which are not more important, and that will try to use that parameter to route to a better result. We take that as a boosting. The result of the previous will come back as a feed or a boost for the next prediction. And you can see all these models are there, 10 models, 10 model parameters also can be given on the front end. And now, what is the age, and what is the blood pressure, what is the specific gravity, what is the albumin count, what is sugar. So if you enter all these details of any person, it can able to say what is the chance whether he will be having chronic kidney disease, whether he is not having chronic kidney disease. So let me go with like this. Here's 59 and blood pressure 80, specific gravity 1.02, albumin 4, sugar level 2, abnormal, I will go with abnormal stuffs, not present, bacteria present, blood glucose 121, blood urea I'll go with 132 something, serum 20.8, sodium go to 123, potassium 3.4, hemoglobin I will go with 7.3, fat cell 44, white cell 9800, red blood cell count 5.2, and I will keep these. Yes, hypertension, diabetes, yes, so coronary artery disease, yes, and there comes the poor, yes, and the final one is yes. So when I enter all these details of any patient, if I ask for the prediction, it says the candidate is having a kidney disease, because we kept so many parameters that says there is a kidney disease, because the main things are here: hypertension, diabetes mellitus. They themselves will tell us, and hepatite, fetal edema, anemia, coronary artery disease, as well as red blood cell count, ps cell counts. So it is a highlight, and most important things: hemoglobin, blood urea, blood pressure, sugar. So all these are most important features that we need for the better detection. So that's the reason we are getting around 100% accuracy, 100% accurate results we are getting, only because we done all the things properly. That is, we propose the things better than the existing paper. Otherwise we could have stuck at 99.3, 99.13, 98.6, 96.4, but we are getting 100% accuracies and precision scores, recall F1 scores, because of the very uniquely presented project. So if you want this code, you can just WhatsApp us to the given number below, attached number below, or you can just call to us and you can discuss. It doesn't mean like you need to take the same project. You can discuss your own idea, unique idea. You can give us any IEEE reference paper better. If you feel if there is any IEEE paper better, you can give it to us, and we'll implement according to that IEEE paper, so that it fulfills your requirement and need, so that you can write paper, you can make report out of it, you can make PPT presentations according to your phases of the project. So we'll be there with you throughout the process. Okay, thank you very much, and in the next class we'll be coming up with some good projects. Thank you very much. Don't forget to subscribe and like our channel.